think so. Hello. 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 I can't tell. Wait. I can't tell if I hear myself or not.
It's coming out the speaker.
Oh. That's what I'm hearing.
Okay, which one is the...
Which one is it?
There's one... Whatever. Okay. Try to get this one, like, on the right side of the guy in the red, so...
I know.
You can try to get the both
Like
of them.
this, right? Okay. Can you hear me? Or wait, no one has headphones? Okay. Okay, so we only have one mic, so you're gonna have to put this on like your right shoulder.
Okay.
And then he's gonna have to talk like kind of close to it. That's okay.
Know how to get up close and personal.
Yeah.
Okay. Probably. Hopefully, we could just hold it in between us.
Yeah.
Instead of hooking it on.
Yeah.
Like this.
Yeah, I guess.
Yeah. Okay.
We could hook it to the laptop and bring the
They
laptop
want-
closer.
Either way.
Okay. 1, 2, 3.
We can
Hook
try.
it on? I don't know about that.
Hook it on to
Oh,
the
he just
laptop.
found another one.
Oh, you found another.
Cool, then
This
we don't
might
even need
hook
it.
this to my tank top.
Honestly, you're probably better off hooking it to your lanyard.
Okay, nice. Testing, 1, 2, 3. I'm struggling.
Will you guys repeat the questions?
Yeah. Somewhat. We'll just,
Okay.
we'll ad lib.
Okay.
Yeah, we're pretty good at that.
Okay. Good to go.
Yeah, I promise we don't bite.
Okay.
Where'd it go? Oh, we're gone.
So when we answer him, do we like answer him to you or do we answer him to the camera?
To me.
Okay.
Alright. If you make a joke, look at the camera like a sitcom.
Break the fourth wall.
Oh, they can't see that. Camera, I don't know why I'm
You're such a narcissist.
not a narcissist. I just
You were
wanna-
staring at yourself over in that TV screen
I'm
over
staring
there.
at everyone, not just myself. I have you know. I used to play this song on the Fortnite Guitar Hero so much. Back
it-
when there's like 20 songs.
Is the music picking up?
Yeah, man.
Okay. Never mind. Okay. Oh wait, do I have to do an intro and everything? I'm not trying to do all that.
There's two of us. What?
What do you do?
There we go.
Did Bryler? Wait, who was Bryler and Bizzle?
It was Briley, Bizzle, and Luis.
Bro, I have to see that. Wait, did they ever air it?
No, because the video wasn't
They
that
say
stuff, so
no.
they couldn't get the video. And then they had the audio, all they had was the audio, but they didn't post it.
Are you gonna
Like, can I have
point
the
to me
audio? I
when
wanna
it's
listen to
I
like
don't think they have it anymore.
good to go?
It was what, last year? 2 years ago? No, it was last year.
Well, how am I supposed to? Okay.
Yeah, you're good. Go ahead.
Bro, am I good? Okay. Welcome to the Point broadcast. Today, I'm here with 2 pre-engineering students, and we're going to be talking about the pre-engineering program and what it has to offer. First off, what is pre-engineering? Why did you choose it out of everything that tech has to offer?
So it's really just an overview class of a lot of different engineering fields. So we've done civil, electrical, aerospace. And I picked it because I was really interested in the science part of it. I like building things and learning how things work.
I was interested in the mechanical part of it. Again, the building things, the making things from the ground up, the designing of different aspects of machines. That always really interested me.
So has this been something like since childhood, or has this like been new, or like what initially did something like spark in you to like say I want to go into pre-engineering?
Well, I wasn't thinking I want to be a mechanical engineer as like a toddler, but like I like playing with Legos
Yeah.
or like the Mega Blocks, the big Legos.
Yeah, what I heard is funny is like, you know, people who like start playing with Legos or start playing like in Minecraft, like Redstone, people who are really good at Redstone, they just like naturally go into engineering. It's like a, what's it called?
Pipeline?
Yeah, pipeline to
Yeah.
engineering. So I thought
That's
that's
kind of
pretty
how
funny.
people's brains work and stuff.
Yeah. So did you feel like you were kind of special from everybody else that, or like that's something like that differentiates you from the rest of tech?
I like to think that, but looking at other engineers, they're just like me. It's a field of people that are just like identical.
Yeah, I mean, we're probably stronger in like science and math part of it, but it's just how we problem solve and learn different things.
So do you feel like because everybody is like kind of similar, that helps with like teamwork? And is teamwork kind of essential in pre-engineering?
Teamwork's really important in engineering. Like we have had group projects, and if we don't get along in those group projects, it's really bad for us.
Can you give an example, like something bad that's happened when you haven't worked together, and like why you think teamwork's essential?
Yeah, so we had this coding project. We had to build a factory, and we couldn't agree on how to like build the code. And in the end, we ended up not getting the code working in time because we couldn't agree on how to build it.
So what have you learned since then to kind of avoid problems like that happening?
We try to give each person in the team their own specific job, but we'll bounce ideas off each other and talk back and forth between each other.
Is it kind of like democratic in the sense, or like do you have kind of autonomy in how you guys work?
I mean, we try to make sure everyone's opinion and like ideas are heard. So we value everyone's opinion in our team, but some opinions just don't work as well as others.
Like engineering, it's like, well, you can have some opinion, but like this one's logically gonna work the best, right?
Yeah.
One, two, three, four, five.
Did you click mute by accident?
No. It's blinking blue.
Good so far?
Yeah.
Battery charge,
Yeah, it's been charging. You said it's blinking?
Yeah, it's blinking blue.
and holds down again.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
No, still not hearing.
Can you hear me?
Try again.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
There it is.
Okay.
Which one are you turning up, Victoria?
Huh? I'm turning it up.
Him up?
Yeah, I'm turning him up.
I'm not sure that was him. I think that's one of the guests. Have him count again.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
No.
Cameron would be really good at this.
4, 5, 6,
Yeah.
7, 8, 9, 10.
He's going to be there on Sunday, so.
Who knew? debating.
Gosh. Oh man, the way you and him argue sometimes.
It's not arguing. It's
You telling him how much of an idiot he is, and him telling you how much of an idiot you are.
yeah, basically.
So it's arguing.
No, it isn't arguing. We get to the point pretty quick. I like to think.
Yeah, somewhat. I wonder why there's only 2 pictures missing.
They haven't made them yet.
Hello, hello.
Maybe there are pictures.
It's just brown.
Yeah, you know, it's what's contemporary. Abstract.
Yeah, $1.2 million.
One, what? What? Okay. Are we ready to go back? Okay. So, how long have you been in pre-engineering, and what has been the most significant aspect of the program?
So this is my 3rd year in engineering, and I think the most significant part has been just the projects we've done and the team we've built over the years.
I think the most significant part is learning how to communicate with others, because there's a fine line between like figuring out how to come to an agreement and arguing, and we ride that line constantly, like the 3 hours a day we're here, just constantly riding in between that line. And I think knowing how to solve problems that's like without arguing, but almost a mixture.
Like kind of debating?
Yeah,
whether
learning how to debate and not turn into an argument is really important, especially in the engineering field, where like 80% of it is like figuring out how to solve this problem or troubleshooting this problem. Like what I hear from engineers is 10% of it's designing it and 90% of it's fixing it.
So I heard are you both 3-year students?
Yes.
So you're both adult students?
No,
Not yet.
we're both 17.
You're both 17?
We're both 17.
Okay,
The
so you started as
pre-engineering,
sophomores?
yeah.
Yes.
Sophomores, I mean? Okay. So because you're in 3 years, so like, has your experience, like, because you've been in there longer, have you had more experience in the field, and have you talked to more engineers and like gotten the feel of what it's like to be an engineer, and are you ready for, you think, the workforce?
Yeah, I don't think we're ready for the workforce. It definitely prepares us for college better, because before I went into this, I didn't know what kind of engineering I wanted to do. I just knew I liked math and science. But now I'm going into mechanical and aerospace at OSU, and I didn't know that before I went here. So it really helped me figure out the field of engineering I went into, and it also just prepared me for the rigor of what college is going to be like figuring out how hard the classes are going to be.
I wouldn't say like necessarily more prepared, because the pre-engineering course is meant to give a broad set of different engineerings. So while like every other class will learn the same thing for 2 years, we'll learn one thing for half a semester and then be done with it. And we'll just bounce back and forth. So while it isn't like workforce ready, it does give you a really good idea of both like what type of engineering you want to do and what it's like in the environment.
So you mentioned you wanted to be in aerospace and mechanical, and I don't think you specified.
I want to go into mechanics and
Okay,
robotics.
mechanics and robotics.
Yeah.
So like, and you said that in the pre-engineering course kind of prepares you for like, it doesn't prepare you for the workforce, it prepares you for like the specialization you want to do, and it prepares you for
Yeah.
pre-college. So I want to know what type of experiences you had that kind of funneled you into mechanical and aerospace, and what funneled you into mechanics and robotics, and how that kind of changed your perspective before and after.
Well, for me, the programs we've done. So we've used a 3D modeling software called Fusion 360, and we've done some Revit, and I enjoyed using those programs. And the projects we did in mechanical and aerospace, they were a lot of fun. We made a glider in aerospace, and we got to launch those in the seminar center over there. And it was cool learning about how the aerodynamics and the different ratios on the plane affected how it flew.
We're having technical difficulties.
Just had to mess it up, didn't you?
It doesn't mess it up.
It's all Chance's fault.
Should have prepared for this better, in all honesty. But
That's good.
So, can you answer the question? What kind of specialization? How did you get into
The
specialization?
factory project we talked about earlier, that's what really, the entire class, the class we made that in was called Computer Integrated Manufacturing, which is basically factory setting machinery, like automatic computer made factories, like, you know, the robot arms you see in like factories that like move things one place to another?
Like the autonomous stuff?
Yeah. That's what really cemented like robotics in my mind, because I love the coding process, I love the building it, I love the combination of like building something and then giving it a brain and giving it a purpose. I really like that.
Okay. So, have any of these projects, I know engineering is of course a hard subject, but I want to know, like, what is the most difficult aspect of that, of pre-engineering? What's the most difficult project of the program, what it has to offer, and like how you would talk to new students or younger students who want to or have interest in engineering? What would you give to them about how difficult it is, and what are some aspects of how like some things might seem difficult but are actually easy or less difficult?
The hardest parts are the test. I mean,
Tests?
yeah, Dr. Applegate's test. Like the first year just took their first Dr. Applegate test, and like the highest score was a 16%.
Yeah, so the tests definitely are hard, but it's just, I underestimated how much I would have to prepare myself for those tests, and that's where the difficulty came for me, is I just didn't expect it to be that hard. The rest of it, the projects are a lot of fun, but there are certain deadlines that they seem kind of impossible to do, but when you actually get out in the lab doing it doesn't seem that bad. Like for our factory design, we had, I think, 2 weeks to make it all, and we had nothing. We had to come up with a design, make
All
what
from
we were
scratch?
actually going to do from scratch, and then build it, code it, and make sure it worked in 2 weeks. And we thought that was going to be insane, but when we actually put pen to paper and got out there and started building it, it went a lot faster than we thought it would.
So would you say pre-engineering helps you develop the kind of skills that, you know, under pressure that you might expect in the workforce?
Oh, absolutely.
What kind of I want to know like what the tests are actually like. Like what kind of test does like a pre-engineering course offer?
So we cover a certain amount of material. We do our block, we do block schedule engineering classes. We do 90 minutes engineering and then usually like 90 minutes of math or science. Over the semester, we'll learn a crash course of the basics of an engineering, like aerospace, for example. We learned like the intro to fluid dynamics. We learned the basics of air traffic control. And then they compile all of that into a test and get like surface level of everything to do with that type of engineering. The problem with it is that the material we cover is surface level, but then you have to study a lot further than surface level. And you have to get like a year's worth of studying done in a block semester. And it's always hard.
Yeah.
So can you say like on average how much studying is necessary for this program, and like what study habits would you recommend for students entering pre-engineering?
Do the homework. Always do the homework, even more than once. Sometimes go through the course again and do practice problems. For civil, we learned like load calculations and stuff. And if you just do some example problems, like make up an imaginary building and do load calculations on that, and then check your answers to see if you did it right, that's really helpful for learning how to use the equations and when to use the equations. Because there's quite a few that you have to learn, and then trying to figure out which one you need to use for the specific problem, that's kind of difficult.
I couldn't imagine doing that. Honestly. I don't even know what you're talking about.
And like the first couple of weeks of a semester, we'll do like one example problem of something, and he'll say, this will be in the final, make sure you memorize it or learn it, and we're like, oh, we'll do that later. And then final coming around, and we have no idea how to do that problem anymore.
Yeah, it's not so bad though, because we are given the formula sheet during the test. There's just so many that we have to know, and then when to use them. That's where the hard part comes in, because we were given the equations to use. We just got to figure out which ones to use.
So I know there's like in college there's like weed out classes that weed out kind of weaker students who like don't have the rigor to prepare for it. So like in pre-engineering, has there ever been a moment where like there's been a test or a quiz so hard that students have like dropped out of the program, or have there been any bad experiences with students that like are in the program but like aren't really dedicated or don't really have experience in the program?
Well, in our specific cohort, it hasn't been much of an issue. We've actually have everyone we had from our first year. We haven't lost anyone. But I know in the morning and some of the second years, they've dropped out after IED, which is the Intro to Engineering and Design, the very first class. So if they can't handle that one, then they're not going to probably be able to handle the rest of them.
Does it like kind of scale up from difficulty like as you progress, or does it kind of get fizzle out once you kind of get past the hard parts?
I mean, once you build up your skills from the beginning level classes, it doesn't necessarily get harder. You just kind of have to use what you already learned. So if you didn't get those base skills built up very strong, the classes are going to get harder. But if you do learn them in the entry level classes, the rest of it's pretty easy.
Do you define that as like compounding skills?
Yes.
Would you say that students should prepare to compound skills, and how would they do that?
Just ask lots of questions. Ask lots of questions. So if you're ever unsure on something, you gotta make sure you're solid on it and understand it.
So I know your class has like kind of two. Do you have two teachers or one teacher?
We have two.
So do you feel like your relationship with your teacher is like a crucial part of the pre-engineering class, or do you feel like it's not that vital or not that as important as it seems?
I mean, it's definitely important because your level of comfortability with your teacher, it kind of gives you confidence to ask questions that you might not ask. Because if you're kind of nervous around that teacher, you don't want to seem stupid by asking a lot of dumb questions. But if you're comfortable with the teacher and you're not like scared to ask questions, then you can ask any kind of question, no matter how dumb you think it might be, because you'll know you'll get an answer that is worthwhile.
Yeah, our teachers will probably spend like 20 minutes lecturing and then 50 minutes answering questions while we do our work.
What experiences like with your teacher can you say has been like something that's changed you in your pre-engineering course?
When we went to Skills USA, that is our kind of competition with engineering, and we're given a project we have to do, and then we have to present that project at Skills. And when we're working on that project, we talk back and forth with our teacher. We ask what works and what doesn't work, and then we revise it from what they say.
Have you won any, what are the pre-engineering, is Skills USA BPA, or is that different?
It's kind of like BPA, but it is more of the vocational and then the engineering and medical stuff.
Okay, can you tell me a little bit about what Skills USA looks like for pre-engineering? Because I know it's kind of different for everybody else, and like what experiences you've had or what kind of competitions you've had.
Yeah, well, there's lots of different competitions. So in my first year, I did this one where it was like a 3D modeling competition, and I had a teammate, and we had to design this coin and then present it and 3D model it and 3D print it and stuff. And I know, which one did Ronnie do last year? He did the...
Me and Ronnie did, Ronnie last year, he did, was it the luggage tag again?
I don't think so. It was the...
It was the same one that Bryler did.
Yeah.
Maybe it was just like a model. Bryler modeled the staircase for the, woodworking students?
We're just given different design prompts, and then we have to complete those.
That's it. Is it that simple?
There's criteria that we're given that we have to follow, And that's where the limitations from our competitions come from. We have to be within that criteria, and we have to have what it requires.
So what do you think some misconceptions are about engineering? Because like I know there's like people that want to be pre-engineering because they watch Iron Man, or they think it's going to be like Tony Stark, and they get into it and it's like learning calculus or something like that. So like what are some misconceptions about pre-engineering or engineering in general compared to what it's actually like and what actual experiences you've had?
You're gonna be at a desk most of the time doing math or figuring out a problem. Like our factory, we built it and then we spend most of the time coding it. Or we spend most of the time designing it. Like we had to figure out what the factory was, figure out the criteria and constraints, name it, design it, figure out the basis of the coding. We build it for like a day and then we go back to coding it. Like,
and it varies from class to class too. Like there's some classes like the civil class, they're doing lots of lab projects right now. So they haven't been out of the lab probably in the last 3 weeks. But for classes like sim, where we did a lot of coding, it is a lot of computer and desk work.
So has that rigor, like, have you talked to actual engineers in the workforce, and have you been able to have established relatability with them at all?
Yeah, so we go on field trips occasionally. Like last year we went to this place called Advanced Plastics. It's a CNC machining shop. And we got to talk to people there who could do what we could do in the future. And that was cool seeing a on-site example of what we could be doing in the future, and seeing where our skills that we're learning now, how they can be applied in the real world. That was interesting to learn.
What was the question again?
Have you had any experiences with engineers, or like in the engineering field, the real field? I'm not talking about and how have you guys established relatability with engineers in the workforce?
Yeah, we've done plenty of field trips and gone and toured engineering buildings before. The engineers that we mainly talk to are the field engineers when we're out touring the factories, but every so often we go and see the engineers at their desk, like on their, when we went, me and Noah, no, he copped out of that one. We went to the Devon building and we shadowed an engineer for a day. And it was really interesting to see what they do. It's a lot more meetings and desk work than I would have ever thought. But they do have to figure out the same stuff we learned, like tolerances and like design and brief and figure out the problem. It's very similar to the actual program we're doing, but also is a lot more like social aspects.
What would you say the social aspects are?
You have to be able to convey your idea and your project to people who may not have the same level of technical understanding as you. So you have to have enough understanding in what you do to be able to explain it to somebody who might not know what you're doing. Like the petroleum engineers, they had to describe their site plans and stuff to people who might not know the specifications and stuff for that type of thing.
Has engineering, like, you have to develop, kind of skills with like talking to other people, and like, do you feel like talking to people that aren't engineers, and do you feel like they kind of don't respect you, or kind of disregard your work, or like kind of,
I think a lot of people just don't really understand what we actually do. And our presenting skills and communication skills are a very big part of what we have to learn so we can get our point across effectively.
The thing is, a lot of engineers don't know what engineers do. Like, it's a confusing field, and trying to explain that to someone that doesn't do engineering and hasn't been there, like Iron Man gives, like, you go out there, you build something, you use it. In reality, you are a part of 100 group people figuring out how to design a doorknob. Like, it's not all that it's hyped up to be, I think.
Well, what I'm kind of saying in that question is like I know engineers work under a project manager, and if the project manager is non-technical, do you kind of feel like that's a bad thing, or would you rather work under a complete technical team, and do you feel like you could be able to communicate better if there's a complete technical team rather than just a project manager that's not really an engineer or like has a really in-depth understanding of like kind of the engineering concepts?
I think you can definitely tell when you're working under somebody who is an engineer and knows their stuff and someone who isn't an engineer. Because the people who aren't engineers, they expect a lot more out of us. Like they think we can perform miracles, but the deadlines that non-engineers give are a lot more unrealistic than what engineers actually give us. Because they can understand what we can actually accomplish in a set amount of time.
You can definitely, yeah, you can tell when someone has been in the field and someone who hasn't been in the field. Like at my job, I don't work in engineering, I work at Taco Bell. But our regional manager, he hasn't worked in the fast food industry for like 40 years, AKA he has no idea what happens. Like I heard him like talking to someone over the phone, and we were like, we're out of every tortilla. Like, can we shut down the store? And he's like, we have tacos, that's what we mostly sell anyways. No, we sell like maybe 1/10 of what we sell is tacos. And he just has no idea. He's so unrealistic. And the things he expects are bogus, they make no sense. And I couldn't imagine doing that in engineering. Like if this guy can't understand a fast food restaurant, I couldn't think of how bad it would be when someone doesn't understand engineering and is trying to boss engineers around.
So like so would you rather, like how would you address that problem of like being under non-engineers?
You just have to really be able to explain your skill set and what is possible for you to do in a set amount of time. You have to be sure that they can understand that. And there's expectations that they need to meet that are reasonable. Like we have to have this project done by this time for our client, you know, but if we want like Iron Man example, if his first generation suit wasn't that impressive, I mean, it was definitely impressive, but if he was expected to do like his Mark IV suit, if he was expected to do that in the same amount of time he had to do the Mark I, then it would not have been pretty at all.
Yeah. I don't know. I just couldn't imagine like I'm working under a field, I get into this, I get all these skills, and then I get into the workforce, and then I'm actually led by someone who has no clue what they're doing, and I just feel like that would just disregard all of the work I've done, and kind of like that's kind of like disrespectful in a way.
I mean, it's not like it's more of an overestimating issue than an underestimating issue. Like they expect more of us than we can actually do.
Well, I don't know, because like we have AI now, so like do you feel like your job is safe like in the workforce? Like have you thought about what you're going to do in the workforce, like in the age of like artificial intelligence, where like the workforce is kind of getting like white collar jobs? I don't know if engineering a white collar job?
Yeah.
So like white collar jobs are kind of getting displaced, and like I don't know how that would affect engineering if everything was this AI engineer, like CAD designs, or like I don't know. What are your thoughts on that?
I mean, I think engineering isn't ever going to get replaced because I don't think AI can perform the critical thinking and problem-solving skills that an actual engineer can. It can be a very useful tool for an engineer. Like if I need to compile this data into something usable and then make a design off of it, I can do that. But if I need to solve a problem that includes people and I need to think about who it can hurt and what the impact could be to the environment and stuff, AI can't think critically enough to do things like that.
Yeah, AI, it's very far away from being able to do an engineer's job. Whenever an engineer makes something, they have to be able to answer why they did this, why they did that, why they did this. And AI couldn't answer those questions. It couldn't redo its design. It couldn't change the design to fit a very specific constraint. And it couldn't communicate with like the other fields. Of course, AI is coming for like every job on a computer, so it may only be a moment of time before AI snatches engineering jobs, but someone's got to be there to tell the AI what to do. So I think that's maybe where my job's safe.
I think like the AI thing is just kind of like capitalistic. Like it's cheaper to use AI than to hire a human. So do you feel like people should pursue engineering not just for the salary, but because they're actually contributing to society in a way?
Yeah, I think one of the easiest fields to see your work is probably civil, because they do the work on building bridges. They build water lines to provide water for cities. I mean, my dad works at an engineering firm, and he's not an engineer, he's a GIS guy, but they do they're working on this one right now. They're doing a pipeline in Arkansas, and it's going to provide water for the entire city of Benton. Like, that is where you can really see the effect of what your work goes into.
Yeah. Building off of his point, there are a lot of engineering jobs where you never get to see the work you've done. Like, we toured a part factory, part machining and designing place, and they showed this wing to a rocket, and they're like, this wing is going to be on the first ever renewable energy plane in 15 years. And they're like, does this wing work? And they're like, no, we're still designing it, and it only may be a wing for the plane. It's funny.
Yeah. So I think our final question, because I've kind of answered every question you need to know. If you could summarize why someone should join the program in a few short sentences, what would you say? How would you tell them what to prepare for? And what would be some words of wisdom that would make them confident in joining the program?
You really gotta enjoy yourself. I mean, it sounds really scary and daunting, but a lot of stuff we've said has kind of been maybe not shedding the best light on engineering, but I've had a great time in this program, and I've learned a lot of things that I think are gonna be useful to me in the future. And you really just gotta go into it with an open mindset, and don't beat yourself up too much if you don't do as good as you think you could. Because as long as you don't quit, you're gonna make it.
Okay.
If you like math, science, and money and Legos, this is the program for you.
Okay. Is that all you?
Yeah.
Okay. I'd like to join you all for. I'd like to thank you all for joining me on the Point broadcast. I'd like to thank my co-host, or my interviewees,
Noah Gustafson.
and
Chance Pearson.
I'll see you on the Point broadcast. Okay. That's it. Thank you.
So we talked so much smack on engineering. That was
Thank you.
rough. We definitely didn't make it sound very fun, I don't think.
I think you can.
Showed more personality of the engineers.
Ooh, these are warm.
When Cameron's here, it'll probably be a bit better than when just me and him, but he's the main talker.
I'm sorry for not getting everything kind of like
Oh, no, it's
arranged.
alright.
That was kind of like on the spot.
He kind of has that effect on people. Is always a problem.
Okay, go, you can stop. Stop the smearing.
Is that it? I guess. Alright. See you guys. Thank you.